So this is the idea about the data warehouse. It is a multi-tiered architecture. We have the data sources. The data sources is the operational data that I mentioned to you before, or maybe some external sources. So for example, in the company, they are the logistic company. So in the logistic company, they need to know the weather. They need to know the temperature because they will manage whether the truck can go or not on the bad weather. Yeah. So sometimes we need to get those external sources data. And those kind of data, it will be transformed into the data storage. If you still remember ETL. What is ETL? Extract, transform, and load. Okay. So we need to extract some data and then transform those data into some particular format and load it into the data storage. Sometimes, it requires monitoring or some administration, and sometimes you need to make the metadata before you enter the data into the data warehouse. After you have the data warehouse, they mention that they may create data marts. So data marts is the small portion of the data warehouse. Maybe you have one big company. So your big company have the production. Your big company also deal with the customer. And your companies also deal with the supplier. So we can separate the data into different subjects. Yeah. And after we have these data marts, we will provide the engine. So we need to put those data into this OLAP. And later on, the data miner, the data scientists, they will extract from this OLAP to make a query or report, to make the analytics, or to make the data mining stuff. So the data mining stuff, it will be better if you have the data warehouse. Do not use this operational data, because the operational data, it is not mature for the data analysis. You need to do many things before you do the analysis. So in the summary, you can see the difference between the operational data. Okay. This is the operational data, or OLTP, and this is the analytical data, or the OLAP. When we deal with the OLTP, usually it is dealing with the IT professionals or the clerk, the frontliner. If you go to the bank, you see the teller. So the teller will ask you, what are you going to do with the bank services? So they're maintaining the operational. Okay. But the OLAP is about the knowledge worker. We need to understand the data. We will analyze the data for the decision support. But what the OLTP is more to day-to-day operations. And the DB design, it is more application oriented. It should be applicable to the real world transaction. But the OLAP is more subject oriented. You want to analyze only the customers, then you will create the customer table, and you will create the customer attribute according to your needs. And the data, it will be the current data, up-to-date data. It will be very detailed, or sometimes it is flat, relational, and isolated. But the data for the analysis, it will be the historical data. Sometimes it is not an updated data. It is last year data. That will be okay because it is for the analysis. And sometimes it is only the summary. And we have the multi-dimensional data, and it has been integrated and it has been consolidated. The usage, it is repetitive because you need to update. Yeah, as I mentioned to you, we have the CRUD. Okay. Yeah, it is repetitive. But the usage for the OLAP is ad hoc. It depends on your need. It depends when you need the data and what kind of analysis. The remaining are just very briefly about the other details like the access. You can read and write. Yeah. In this OLAP, you will do the scanning, most of the things. And then the unit of works, it is the transaction, and usually it is short. But in the OLAP, you need to have the complex query. So that's why if you learn about the data analytics, okay, we have the job for the data scientists. We have the job for the data engineering, data engineer, or data analytics. So the data engineer, usually, they will do the complex query. You need to understand the SQL. You need to understand how to extract the data from the database. For the data science, you need to know what is the data, how to create the attribute, how to transform the attribute. For the data analytics, usually the person who understands about data mining, they will do the analysis on the data. So the complex query, people from the computer science who understand the SQL, or maybe they are the data engineer. And the record, it can be only very small because it is transaction. When you do with the OLAP, there will be millions. And the number of users, because it is transactional, there will be many users, maybe thousands or millions. But for the OLAP, only some person will access it. Maybe only the directors, or maybe only the analysts. The DB size, maybe this one is because transactional, you need to prepare only giga something. But for the OLAP, the data warehouse should be big because it contains 10 years data. So it includes many data. And the metric is transactional. But this metric is more about the query. So why a separate data warehouse? Because we need to have the high performance. The high performance, it means if you are dealing with the OLTP, you need to have the high performance for transactional. If you are dealing with the OLAP, of course, you need to have also a high performance for this OLAP. You need to have different, or you have to separate those systems, because every of this one, they need high performance. The DBMS, we have access, we can index it, or we can do the concurrency control, or sometimes we need to do recovery. So this requires high performance. For the data warehouse, we need to do the complex queries, and it is multi-dimensional, and you need to do something about the consolidation. So it requires high performance. That's why we need to separate OLTP and OLAP. And different functions will have different data. When you are doing with the operational data, they don't care missing value. They just care about the transaction. If you are the new member, if you go to the bank, they will ask only your ID, your name, your birthday, your phone number, your signature, finish. But maybe in the attribute of the database, it includes many things. So many missing data in the transactional database. If you want to do the analysis, what happened? You can see a lot of missing data, and then you need to delete that one before you do the analysis. So that's why it has different function between the operational and the analysis. Data consolidation. DS, decision support, requires consolidation. So sometimes you need to aggregate. Sometimes you need to summarize from the heterogeneous sources. And data quality. Different sources typically use inconsistent data representations, codes, formats, which have to be reconciled. Foreign websites usually have no consistency. Sometimes they want you to input the address with row, but sometimes they want to give you the input with DOM. So there are some inconsistency with that one, or maybe some Korean website they use the previous address. So that kind of quality will make a confusion on the data that you will save. So the data warehouse should include this kind of operation, and in the operational, they don't care. So there are more and more systems which perform OLAP analysis directly from the relational database. So this note, nowadays, because the performance of the database is getting good, better and better. So some companies, they try to do this OLAP from the relational database, or maybe it's from the transactional database. So three kind of data warehouse models. We can make an enterprise data warehouse or enterprise warehouse. It collects all the information about subjects spanning the entire organization. So we call it enterprise. Because all the things in the enterprise will be in the data warehouse. Or data mart. It is a subset of a corporate-wide data that is of value to a specific group of users. So we can make data mart for only the products. We can make the data mart only for the employees. We can make the data mart only for the suppliers. Its scope is confined to specific selected groups such as marketing data mart. And it is independent or dependent from the data warehouse. You can have in the same data warehouse, or you can specify in the data mart. Or we can have this virtual warehouse. This virtual warehouse means if you are understanding the operational database, in the database, you can do query. Query means you will extract some condition from the data, and you can also do view. So when you do the view, it means after you do the query, you will put all those results into the view. That's what we call as the virtual warehouse. It is a set of views over the operational database. Only some of the possible summary views may be materialized. So after you know what is the query, you put into the views and you will do the analysis only based on the view. We call it, this is the virtual warehouse. The ETL. So you already learned the ETL before. It is the extraction. It means we will get the data from multiple heterogeneous and external sources. You need to do the cleaning. So you need to detect the errors in the data and rectify them when possible. And you need to transform. Transform means you need to convert the data from the legacy or source format to the warehouse format. And you need to load it. Load means you need to sort, you need to summarize, you can consolidate, you can compute views, check integrity, and build some indexes and partitions. And then at the end, you need to refresh because you need to update the data source. Usually you will update 3 months, 6 months, 1 year. It depends on needs. Okay. So mention 4 characteristics of data warehouse. What are they? We have the subject oriented. And then we have the characteristic is time variant. And then we know that the data warehouse should be integrated. And it is a non-volatile. So this is the 4 characteristics of the data warehouse. What is the main difference between OLTP and OLAP? OLTP, yeah, based on the words, it is for the transactional or operational. The OLAP, it is for the historical data. It will be used for the decision support. Or yeah, we can say this is for the analytical purpose. So there are 3 kind of data warehouse models. Can you mention them? We have the enterprise warehouse. And then we have the data mart. And we have the virtual warehouse. The enterprise warehouse, it means the entire organization or the entire company. The data mart is the subset of this organization. And the virtual warehouse is a set of views from the operational database. Okay, so that's the summary. Explain the main task in the ETL. E means extract. When we do the extraction means, yeah, we can do something like data cleaning. T means transform. So you learn about the transformation in the previous chapters. And then L means load. So load, it means, yeah, we can do many things like the summarization. We can do, yeah, many things for the loading. It depends on the data. Like you already know the transform, it is about the binning. Yeah, it is also one of the transformation approach. Or maybe you want to do with the histogram analysis. So those kind of things are in the transform. When you do the load, yeah, you can do the summarization, or you can do with more analysis, like yeah, you can sort or you can consolidate the data. You will check the integrity or building the indexes. So those are the loading. Okay. We will learn some of the models on the data warehouse. We have the data cube and OLAP. We want to create from the database tables to the data cubes. The database tables to the data cubes means, yeah, we want to create the smaller portion of the data. A data warehouse is based on the multi-dimensional data model, which views in the form of a data cube. Okay, the keyword is multi-dimensional data model. If you have the cube, we can have another cube. So the other cube should be representing almost similar, yeah, with maybe we can see this one in the 3 dimension. If you have more dimension, of course, it will be more complex. So a data cube such as sales allows data to be modeled or viewed in the multiple dimension. That's why we will have dimension tables. The dimension tables is about the item or is about the time. So the item can be the item brand or the brand type. The time, it can be day, week, month, quarter, or year. And we will have fact table. Fact table, it contains the measures. So what you want to check. Let's say I want to see the sales. So I want to see how many dollars that we already do the sales, or yeah, how many credit that we can get from the customers and so on. It is the keys to each of the related dimensional tables. In the data warehousing literatures, we have the ND base cube. N means the number of data and D is the dimensional base cube. The top is 0D cuboid, which holds the highest level of summarization, and we call it the apex cuboid. The lattice of cuboids forms a data cube. Let's see this small example. Okay. I have a daily transaction data. When you have the transactional data, you will put the data into different database. We have the customer table, we have the item table, and we have the location table. So the customer table, maybe this one is 01. The person name is Gildo. And then date of birth is this one, and the address is in Mohiam. The customer 2, this name, this is date of birth, and this is the address, and so on. Okay. About the item table, yeah, it is the item name, it is the price, and then this is the supplier. This is name, price, and supplier. And the location table means the store. Let's say this is the Yongin branch, it is located in Yongin. This is the Bundang branch, it is located in Bundang. So let's say in the transaction 1, I have this transaction. Hong Gildong purchased the LG TV 45-inch at Yongin branch in 2020, paying Osiman. The transaction 2, this is the customer name, purchase Samsung refrigerator, this type, at Pundang branch in 2020, paying back is Oman. Okay. Then we will have sales table. The sales table will include, because we know that this is the transaction ID, so it will include the customer name, it will include the item name, and it will show the location name, and it will start the date and the amount. So we have this sales table, and this sales table, we can create based on the attribute. If, for example, for this data cube or the sales cube, I can separate it into three kind of things: time, location, and item. So every cell contains the sales amount for a specific item at specific location during specific time. So we want, because we know we have a lot of items, we know we have a lot of location, and we know that we have many times. So we can make it into a small cube. Let's say I want to know the total sales of LG TV at the Yongin branch in only March 2020. So we can have like the dimension. We learn about the concept hierarchy generation. So we just make a very simple time. Make sure that the time does not overlap. So the day, engage the day, and then it will go to the higher concept, which is month. It will go to the higher concept, maybe the quarter or year. If we use week, there might be some overlap. So this is the cube that we can create. If we have, let's say, 4 attributes, we want to separate the time, item, and location and supplier. We call it, this is a base cube. And the 0 dimension, it means we call it the apex cuboid. The apex cuboid means we want to include all data. But this 4D base cuboid means we want to separate for each of these items. What about if we have 3D cuboids? Then we have the combination between the 3 attributes. Maybe we will have only item, location, and supplier. Or maybe we have only the time, item, and supplier. Or maybe we have the time, item, and location. We can also have the time, location, and supplier. If we are dealing with the 2D, it means we have only 2 different attributes. If we have 1D, we deal only with the 1 attribute. So this is the combination, because this is the lattice of cuboids. If you have 4 attributes in your table, you can create the combination based on this cube. So it means you know that how many possibilities you can make the data cube. Okay, I guess I can stop here. Okay.